What's up, guys? Welcome back to my YouTube channel. It is time for Coffee and Math with Miss Donovan. I'm so happy to have you joining me today. If you want more content like this, make sure to smash that like button and turn your books to page 139. And make sure, because again, I've had so many of you say, I didn't know we had to take notes, so I'm telling you right now that you guys not only need to watch the video, but you need to take notes. So any examples I do, any problems we do, you need to copy them in your workbook. If you don't have your workbook, write them on a separate sheet of paper. But in order for you to get credit for doing this assignment, I need to see your notes. So pause the video if you need to, go get your workbook and open to page 139, or go get your piece of paper, and I don't know how this is going to look. I think I might have written over. I can't see what I'm writing, so I know it writes, but I can't see it, so we'll see what happens. But anyway, we are going to continue talking about subtraction. So you guys learned a little bit about chip models in class today, and we are just going to review subtraction quickly with a few other examples that we're going to look at. So for this lesson, we're going to first look at integers. What is an integer? So we've been talking about adding and subtracting integers. You need to know what an integer is. So basically an integer is just a whole number and their opposite. So we'll just look through here at Integersy, the most interesting woman in the world. Integersy is a world-renowned record breaker. She knows all about integers because they represent her achievements and her limitless potential. Time can be represented with an integer. 9 hours, 540 minutes, 9 and 540 are both integers. 8 and 14/15 is not an integer because it is a mixed number. So not an integer right here, not an integer because it's a mixed number. So anything with a fraction or decimal is not an integer. Integers, derived from the Latin word for complete, are infinitely countable, so they go to negative infinity and positive infinity. And so here's a few other facts for you. We can use integers to represent measurements, so I'll let you guys read this. Runs and innings are counted in whole numbers and therefore are integers. When altitude reaches 0 feet or meters, that represents sea level. So anything above sea level is a positive integer. Anything below sea level would be a negative integer. So integers are everywhere. And we are going to spend some time learning operations with integers in this chapter. So just a quick review here. What happened to my... When we want to subtract integers, remember that we can use a number line. So if I have positive 4 minus 9, I can go to positive 4 and then take 9 away, and that takes us to negative 5. We can use a vertical number line. I'm not going to use this one too much. But there's some rules when subtracting integers. So this is on the top of page 140. To subtract an integer, we can add the additive inverse of the integer, remember, which is kind of the same as the opposite. So if I have p minus q, it's the same as p plus the opposite of q. Or with an example here, 4 minus 9, I can change subtraction to addition and change 9 to negative 9, and then we can apply the rules we used for adding integers to make this negative 5. So again, I'm going to show you one way. We looked at chips in class, and if we use a chip model, you guys know that if I have 5 positives, I can't take away 7 negatives, so I have to add 7 negatives into there to be able to take 7 zero pairs, I should say, to be able to take 7 negatives away. So you can think about and use the chip model if that helps you. But we're going to look at this as copy, add, opposite is how some people learned it. But I'm just going to show you this. We're going to take 5, and instead of minus, I'm going to change that to addition. And instead of negative 7, we're going to make that 7. So really this becomes 5 plus 7, which equals 12. So if you remember how we did addition, then we're going to do subtraction the same way. Didn't want that. Okay, let's go here. Anyway, so if we have 10 minus negative 19, we can write this as 10 plus, and then what would it be? Think about it. Positive 19. So I'm going to change copy. We're going to copy the first number, we're going to change it to addition, and then we're going to make this the opposite. So we're going to add the additive inverse, which equals positive 29 there. So now you guys, on the bottom of page 140, at the bottom, there is a check problem. I would like you to try that one and see how you do with that one. So pause the video and try that check problem. We're just going to go through a few other examples here. So negative 24 minus negative 17. Again, we're going to make this negative 24 plus positive 17. So a negative plus a positive, remember what we did there, we would have to do 24 minus 17, which is 7. But since my bigger number, bigger, quote-unquote, bigger number, is negative, my answer will be negative 7. So again, we're going to change this to an addition problem and then use the rules we talked about when we were adding integers. So if we're adding and they are, we have one of each, one positive, one negative, we actually subtract the numbers and then take the sign of the number with the larger absolute value. So same thing here, we are going to copy the first number and change subtraction to addition, and then that negative 45 becomes a positive 45. But since the first number is negative and the second number is positive, we will actually subtract 45 minus 31 to get 14. And since our larger number is positive, then our answer is going to be positive, because we have more positives than negatives. So if we're going to add and we have more positives than negatives, then our final answer is going to be positive. Okay, so try on page 141 at the top. At page 141, you see a check problem, negative 39 minus negative 24. You guys pause and try that one right now. Then go back to page 141, and now we are going to not only subtract, but evaluate expressions. So if we want to evaluate x minus y, if x is negative 23 and y is 19, then all this means is we need to find the value of this expression. So that word evaluate, you see value in there, we want to find the value of this, which means we want a single number value for our answer. So we're going to replace x with negative 23 and y with 19. And we're going to use parentheses here. Anytime you put a number in place of a variable, it's a good idea to use parentheses. I even like to use parentheses around the x as well, especially when you're working with negatives. But now we have negative 23 minus 19. So just replacing x with this and y with this. So negative 23 minus 19. Again, we're going to change this to addition, and instead of positive 19, we have negative 19. And now our rules of addition, if I have a negative plus a negative, since they have the same sign, we add them, and our answer is negative. So final answer here is negative 42. They give you the answer, and then they want you to put the answer. It's kind of silly. So let's look at another example here. If m is negative 23, so I'm going to use parentheses there, and n is 44, what does this equal? So negative 23 minus 44. We could write this as negative 23 plus negative 44. And again, since now we have a negative plus a negative, we would add those two numbers, and that is 67. But since they're both negative, my final answer is negative. And I hope that the numbers look good, because literally I know it shows up on your screen, but I can't see it, so I can't see what I'm writing. So hopefully it's not too messy as you guys are watching this. So now on page 141, at the bottom, there is another check problem similar to these two examples. So why don't you try that check problem on the bottom of page 141. Okay, so the next thing is finding the distance between integers. And here's a short video for you guys to watch.
One way to find the distance between two integers is by using a number line. Start by plotting the two integers on the number line. Next, count the number of units between the integers. Counting the number of units shows that the distance between negative 4 and 5 is 9 units. You can also find the distance between two integers by using an expression. The distance between two integers is equal to the absolute value of their difference. Begin by writing an expression that shows the difference of the two integers between absolute value bars. Now simplify the expression. First, subtract the integers. Then find the absolute value. This method also shows that the distance between negative 4 and 5 is 9 units.
So this is actually on page 142. There's some places to fill in here. You can fill in these answers on the bottom of page 142. But what we're really doing is just finding the distance between 2 points is just the difference between those two integers. So let's look at a few examples. If I want to find the distance between negative 9 and 8, then let's look at those on a number line first of all. So here's negative 9, and we're going to go all the way to 8. Look at that. What is that distance? Well, that little bouncy ball traveled 17 units. And if you think about it, if I subtract negative 9 minus 8, then we get negative 17, and the absolute value of that is positive 17. So we can find the difference and then take the absolute value of the difference, because distance is really positive. The reason we take absolute value is because it's a positive number. Distance can't be negative, so distance is always going to be positive here. And just really quick, so that this doesn't take too much longer of a video, we want to find the distance between negative 12 and 7. So again, we can just subtract those two numbers, negative 12 minus 7, which would be negative 12 plus negative 7, to give us negative 19. And again, you can pause this at any time if I'm going too fast and rewatch this. But the absolute value of negative 19 is positive 19. So our final answer for this one is positive 19. And the last thing for this video is, again, you're going to see some that are more like word problems. So if we want to find the distance between the highest point in California and the lowest point, which is Death Valley, at negative 282, then the distance is going to be, again, the difference. So we are going to subtract those two numbers. Okay. And our absolute value is 14,776. So that's all for this video. I don't want to keep it too much longer. I tried to keep them around 15 minutes. You guys, let me know if you have any questions. Try the check problem on the bottom of page 144 and draw 3 check marks next to that check problem so I know that you have watched all the way to the end. Have a good rest of your day.